Hi dear students, hope you are staying safe at home and you are doing well. Um, now we move to lesson 6 and we start to study lesson 6. And now I'm going to cover pages between 151 to 154. First of all, we need to focus on relative relative atomic mass, which is a subclass of title chemical analysis and formula. Long time ago, mass spectrometer was used to measure of hydrogen atom. Okay, so scientists were obtained this number 1.7 times 10 power minus 24 gram for hydrogen atoms, and they convert to the gram. Okay, it was the unit was gram, but actually this number is very difficult to use. Okay, we cannot use this number for multiplication with others and compare with others. You cannot use it in scientific equations. So, uh, 12 hydrogen atoms were used to measure one carbon atom. They found that if we um, add 12 hydrogen atom, we can reach equal with one carbon atom. That means one carbon atom's weight or mass is equal with 12 hydrogen atoms. Okay, they are equal. And also, they found if they add four hydrogen atoms, it's equal with one helium atom. So they use this term relative atomic mass. That means this is only a comparison. It's not exact a mass of the atom. They are a comparison. Use they just measure the hydrogen atom mass and they compare with the other atoms. They got many atomic mass for carbon, helium, and the rest of elements, all elements. So if you refer to periodic table, you can see that each element has own atomic mass, but this is actually relative atomic mass, not exactly. They were compared to each other, and uh, like here they put 12 unit for carbon, and each hydrogen atoms got one because each carbon has is equal with 12 12 hydrogen atoms. So they put 12 for carbon, one for hydrogen. So that was called relative atomic mass, AR. There are some notes for relative atomic mass. Here first you can see the all relative atomic mass for many important elements like hydrogen, carbon. Okay, the carbon is 12. That means 12 times heavier than hydrogen. Okay, one carbon is 12 times heavier than hydrogen. And nitrogen, like nitrogen is heavier than carbon, is 14, and oxygen is heavier, and fluorine, sodium, magnesium, aluminium, sulfur, chlorine, and copper. Okay, um, your book actually has rounded this number. Okay, this can be like 12 point something or 11 point, it's actually 11.99, but this number has rounded. As I said before, relative atomic mass is not the exact atomic mass. Okay, they compare to each other and these numbers were obtained. Relative atomic mass is an average of the atomic mass of different isotopics. Uh, as we studied before, for example, carbon has three isotopes, and nitrogen can has two isotopes. Okay, each isotope has their own mass number. They have different. Each atom has different isotope, and isotope has their own uh, atomic mass. So for each atom, those numbers were averaged. Okay, so we have one unique number for each atoms. And another note is relative atomic mass of ions is same with their parent atom. What does mean? Means, for example, we have sodium cation, right? Sodium cation is the parent atom is sodium, in fact. So the sodium, if they lose one electron, it can be converted to sodium cation. So sodium just lose one electron. One electron doesn't have like very significant mass, so it can be ignored. Okay. Um, Losing electrons or receiving electron can be ignored because electron doesn't have a significant or considerable mass. So atomic mass of cation sodium is same with the atom form, the form of atom. And oxygen, like oxygen and iron, 2 minus can be same. Yeah, it's same with oxygen. Both are 16. What is relative formula mass? The total mass of a substance can be calculated by sum of all individual atomic mass. We can say relative formula mass. Also, we can say relative molecular mass. Okay, is same. These two terms is same. Both are obtained from the formula. For example, formula of the hydrogen gas is H2. We have two hydrogen atoms. Each hydrogen has 1. Okay, the atomic mass is 1. So 1 plus 1 is 2. So relative formula or relative molecular mass of the hydrogen gas is 2. For water, is same strategy. We have two hydrogen, we have one oxygen. For each hydrogen atom, we have 1 and 1 plus 1, and oxygen is 16. So the total would be 18. 18 is a relative formula mass or relative molecular mass of water. For sulfuric acid, which is H2SO4, means we have two hydrogen, we have one sulfur, and we have 4 oxygen. So for 2 hydrogen we have 2, total 2, and sulfur is 32, and for oxygen we have 4 times 16. The total, the sum of all individual atomic mass will be 98. Okay, as you refer to the table here, sulfur is 32 and oxygen is 16, carbon is 12, and hydrogen. These are this table is available in your book, and you can refer to this table. These are arrangements of the most important atomic mass. One more example for carbon dioxide. Uh, Another things that you need to know is if you refer to periodic table, the atomic mass is available in on the bottom of each element. For example, for carbon, the atomic number is 6. We studied before about atomic number, which is equal with the number of electrons or protons are same. But the below one, this number is showing the atomic mass. Okay, so if you want the atomic mass for all elements, you can check on periodic table. These number are belong to atomic mass. So for carbon dioxide, we have one carbon, which is 12. We have two oxygen, which is 16, but 216 is 32, and the total atomic not atomic total molecular mass, relative molecular mass, would be 44 uh, for carbon dioxide. You need to do two more steps to get a percentage by mass of a particular elements. Uh, First, it depends which element you want to get its percentage. It is important because uh, if you notice for any product in market, uh, usually company or factory label on the pack. For example, any product that you use from the market, like biscuit, chips, Coca-Cola, any product, you can refer to the labels, and the label can show you the percentage of a vitamin or protein, carbohydrate. They can be calculated with same strategy, same method. This is important for any products, and that to get a percentage of the mass of compound. Here, for example, if we want to get a percentage, the percentage of a nitrogen, first of all, as the same the previous one, we can calculate the total number, the total relative molecular mass. Okay, for here the example is ammonium nitrate. Okay, ammonium nitrate, the total relative molecular mass is 18, and you can another step is to calculate only the nitrogen. Okay, the nitrogen, here we have two nitrogen. Okay, one is here and another one is here, so we have two nitrogen. The two nitrogen is 14, the two nitrogen only is 28. So we have only 4 nitrogen, and we have the total is 18. So we need to divide, okay, make a fraction, one nitrogen, okay, the total nitrogen from the total molecular mass. Then after that you need to multiply to 100. Okay, after that you need to multiply to 100. Then the rest you will get the result for percentage of, here is nitrogen, percentage of the nitrogen from this ammonium nitrate, from the substance. One more example is here. uh, we are going to get the percentage of here percentage of the water. Okay, we have a bigger molecular. We want to calculate the percentage of the water in this substance. So uh, as we calculated previously, we can uh, measure the total molecular relative molecular mass of the compound is 246. Separately, we have to calculate the water. Only water is 126 because there is 7. Okay, we have 7 water molecule. Okay, it's 126, and it must be like multiply 7 multiply for water. Then after that we need to divide 100 water from the total number like this. And the next one we need to multiply to uh, multiply to 100 because it's percentage from 100%. Then you can measure the rest. Okay, I mean the result. You can measure the result is 51.2%. We have water in this formula, big molecule. uh, you need to give you need to give to this answer to this question. We have uh, three substance. A, ammonium sulfate. Okay, you need to calculate the percentage of the nitrogen. Okay, only you need to measure for the nitrogen one because this compound has the nitrogen. Okay, this compound have nitrogen. You need to measure only the percentage of the nitrogen. The following these are fertilizers, and these are nitrogen containing compound or ori. And glycine is a type of uh, amino acid. Okay, this is your task, and please uh, give answer to this question. Thank you so much. That's all for today.